Good morning or good afternoon, as the case may be. My name is Sosale Mohana. I'm a maths teacher who has taught maths for over 50 years in 3 continents and 3 countries, like India, in Asia, Kenya in Africa, and England in Europe. I've just retired a couple of years ago, and I thought I should use my experience to record and deliver a number of lessons based on the British curriculum for A-level maths, so the students who want to reinforce their learning can use it. I have a master's in maths, of course, way back in 1969. I completed my master's in maths, and then I did my teacher training in 1974. I've been working since 1969 till 2019, clear 50 years. So I hope these lessons are useful to you, and you're welcome to watch them, and then with each lesson, there will always be a document which covers whatever has been done in the lesson, so you could use that perhaps as your own notes, or maybe to go over what has been taught during the lesson. I hope you enjoy the lesson. Hello everyone. In the last lesson, we dealt with transformations, how a graph of a function is given, and you can find the graphs where graphs of functions that could move to the right, that could move to the left, that are stretched up and down and reflected in x-axis, reflected in y-axis. But then we proceed further. We are still on to graphs. So today, to start with, I'll be talking about sketching quadratic curves. So easiest way would be I think it's better to take an example instead of just talking with all A's and B's and C's. So let's say, for example, sketch y equal to x squared minus 6x minus, let's take 16. Obviously, when I go through the steps, when they sketch, we don't expect you to draw x-axis, y-axis on a graph sheet and plot 1, 2, 3, 4, 1, 2, 3, 4 and do it. No. But at the same time, your sketch should bring out the important aspects of the curve. So to do that, we need to know where is it going to turn, the U, where is the bottommost point, because it's a plus U shape. So to do all that, step number 1 will be to complete squares. So don't complete squares, it's a positive x squared. Whenever it is a positive x squared, you write it as a px plus q whole squared plus r. That's indirectly, I'm making it into a square and a number. So why do we do this will become obvious when I sketch the curve. So it is p squared x squared plus 2pqx plus q squared plus r. Remember, I'm putting 3, that means they are identical to. If they're identical, the coefficients must be the same. And whenever you take the square root, in this case, because it's a positive x squared, p has to be positive. So therefore, p squared is 1, gives you p equal to 1. Compare x with x. So 2pq equals minus 6. P is 1. So 2q is minus 6. So q is minus 3. And then the constant term here must be equal to the constant term there. So q squared plus r equal to minus 16. 9 plus r is minus 16. R is minus 25. Why do we do all that? Because, so I would be able to write the question as y equal to px plus q whole squared plus r. Now when you look at this, when you put x as 3, that becomes 0. And that's minus 25. So in other words, x equal to 3, y equal to 25 is a minimum point. Why is it a minimum point? Because we know it's a plus x squared, a is positive, so it's a U-shaped graph, so it will have a minimum. Apart from that, x equal to 3 will be a line of symmetry. In other words, when you sketch, I need to know what's the minimum point. I need to know if there is any symmetry. Okay, good. And then we go back to your basics. When x is 0, y is minus 16. And then when y is 0, it is x minus 8 times x plus 2 equal to 0. So x equal to 8, x equal to minus 2. I have all the information I need now to sketch the curve. So remember, whenever it's a plus x squared, use px plus q whole squared plus r. If it is a minus x squared, we will use r minus px plus q whole squared. That's the reason why this is another way of completing the squares. In fact, if you have to complete squares in the exam, you can as well use this method to solve a quadratic using completing squares, as I'll show you here just out of interest. So if the question said, use complete squares and solve, I've taught you before. So divide throughout by the coefficient of x, agreed, and take half the coefficient of x, half of minus x is minus 3, square it, minus 9, you add minus 9. So let me just do that. So x squared minus 6x, half the coefficient of 6, minus 6 is minus 3, minus 6 squared is 9. So you add a 9 equal to 16 plus 9. So you get x minus 3 whole squared equal to 25, which you could get because remember, when I did this, I had x minus 3 whole squared minus 25 is 0. From there, I could straight away get the same answer. So this is also completing squares, and it is much easier because you don't have to worry about what the quotient of x, what the quotient of x squared. Don't have to do that. Great. So therefore, if I now draw the sketch, it's a freehand sketch. It doesn't have to be it. So please use a ruler and pencil. Freehand doesn't mean draw the way I'm drawing. When x is 0, y is minus 16. Just put 0 minus 16 somewhere. And when y is 0, x is minus 2, and then x is 8. And remember, if the two roots are there, the point of symmetry will be exactly halfway between those two. That is 3. And that will be the minimum point, 3 and minus 25. So that's your graph. That's 8, and that's minus 2, and that's minus 16. And that is your x. Please indicate what axis you have and indicate the coordinates, that point, that point, that point, that point, and the shape. That's how you draw the graph. Pretty simple and straightforward. But then, not everything is that easy. Suppose you were asked to, so that was about quadratic. But what if you're asked to sketch a cubic curve or a 4-degree curve? So in other words, graphs of polynomials. Normally, we will not go beyond power 4 at A level. So for example, let's say you got y is equal to x plus 2 times x minus 1 times x minus 2. Something like that. Just have to sketch the graph. Later on, we'll look at maximum, minimum, everything. So what we do is draw x-axis, y-axis, put x equal to 0, y is 2 minus 2 times minus 2, 4. So 0, 4 is a point. Either you work out or show on the graph. The roots are minus 1, 0, minus 2, 0, somewhere there, and then 1 0 and then 2 0. Look, your graph has to go through all these points. So what you do is look at what happens if it is less than minus 2. If it is less than minus 2, that's going to be negative. That is negative. That is negative. The whole thing is negative. So it will be somewhere there. Between 1 and 2, say take 1.5. That's positive. That's positive, but that's negative. So that's going to be negative. So your graph is negative here. Your graph is negative there. So I don't know what these points are. I'm not saying that it's a maximum there. In fact, you can go like that. It doesn't matter. The point I'm trying to make is the general shape. And that's all we're interested in, because generally such questions come when you're asked to solve an inequality. Whereas I might have y equal to x plus 2 whole squared times x minus 1. So that is when x equal to 0, therefore y will be minus 2. When y is 0, x is minus 2 repeated root. Remember, it's a whole squared. And then x equal to 1. Whenever a root repeats, x-axis will be a tangent at that point. It could be x plus 2 whole cube, it could be x plus 2 power 4. As long as a root repeats, x-axis will be a tangent at that point. So if I am drawing the graph, I know now at minus 2, there are two roots. So either at minus 2, either the graph will be like this or like that. I have to decide which way. When x is 0, y is minus 2, and when x is 1, y is 0. So look, this part of the graph has to go like that. So it will touch and go down, and somewhere there it goes up. That will be the graph. If you're asked to sketch this in the examiner will be looking at that point where the x-axis is a tangent to the curve. Similarly, we can do for 4 degree and so on. Of course, a 4 degree curve could be a quadratic graph. Be careful. For example, something like x power 4 minus, let's say 6x squared, minus 5x squared plus 6, y equal to. If I were to equate that to 0, what would I get? I would get y equal to, suppose you were to call x squared as t. If you call x squared as t, that will become y equal to t squared minus 5t plus 6. So if you put y equal to 0, I get t minus 3 times t minus 2 equal to 0. So t equal to 3, t equal to 2. So x squared equal to 3, x squared equal to 2. Remember, when you take a square root, take both plus and minus. So x is plus minus root 3, x is plus minus root 2. So this one will have 4 roots. 1, minus root 2, and minus root 3. That's minus root 2, that's minus root 3, that is root 2, and then root 3. Then you will have to take a value between these two. This is minus 1.7, minus 1.4. What happens at minus 1.5? Minus 1.5. I need my calculator. I can't use this. I have to use this. Minus 1.5. Bracket. Oh, I need my glasses. Sorry, I'm an old man. You know by now. Bracket minus 1.5 close bracket power 4 minus 5 bracket minus 1.5 squared. I can just put it as 1.5 squared. I could have done the same thing in the first one, I agree. 1.5 squared plus 6 is minus. So between these two, the graph is minus. When x is 0, it is plus. So look, this graph comes somewhere like that, goes there. I'm squeezing the graph, so it has to be somewhere like that. A nice W-shaped graph. That reminds me of an old American movie about the cannonball race, I think, if I'm correct, where people start chasing a big box of money a robber has put under a tree, and there they said, look for a big W. So the trees were like this. So there were one tree like this, one tree like this, one tree like this, one tree like this. I think it was Spencer Tracy. Very funny movie. Cannonball Race, if I'm correct. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.